Hello dear students, a warm welcome to you all. In this session, we will be discussing the topic constructions. Before moving on to the main topic, let's have an overview about the subtopics that we will be learning in this chapter. The first one will be division of a line segment, followed by construction of similar triangles using scaling factor, then tangents to a circle, and then tangents to two circles. Now let's begin with division of a line segment. Let's have a look at the question. Draw a line segment of length 7.6 centimeter and divide it in the ratio 2:5. Measure the two parts. So let's begin. So we have to draw a line segment of length 7.6 centimeter. So let AB be the line which measures 7.6 centimeter. Now from A, draw a line AX and we are given the ratio is 2:5. Now which means that there are two parts and there are 5 parts. Now total will be 7 parts. So if C is the point that is dividing the line AB into 2:5, then out of 7 parts, 2 parts is what constituted by CA and 5 parts is what is made up by CB. So there are total 7 parts. So make 7 divisions on the line AX, namely A1, A2, A3, A4, A5, A6 and A7. Now from A7, that is the endmost division, join B, that is the end of our line segment. So join A7 and B. Now with A7 as center and A6, A7 as radius, draw an arc which cuts the line that joins A7 and B, as you can see in the figure. Now with the same radius and A2 as center. Why 2? Because in the ratio it's 2:5. So with A2 as center and the same radius, draw another arc. That be second arc number 2. Now using the compass, take the width of A6 and A7B, take that width. Now bring that same radius to the other arc number 2, and with A1 as center, cut the third arc so that it will meet arc 2. So arc 2 and arc 3 are intersecting. Now join the division A2 with that intersecting and connect it to the line AB. Now let that point where the new line touches AB be C. Now we have got a point C that is dividing AB in the ratio 2:5. That's it in this construction. Now for the examination, you will have to write the steps of construction like I explained right now, but there is a general step on how we have to construct the line that is being divided into some ratio. So let's have a look at it. We have to draw the line segment with specified length. Then from one end, draw another line with M plus N divisions, where M is to N is the ratio. Like in this case, 2:5 was the ratio, so we took 2 plus 5, that is 7 divisions on the new line, that is AX. Now connect the last division to the other end of the line segment, A7 to B, that's what we mean by that. Now from mth division, draw a line parallel to the line drawn in step 3. What is the line in step 3? A7B. So from mth division, that is A2 in this case, draw a line parallel to A7B. That's how we got the point C. Now the same question can be done in another method. So there is an alternative method for this. Let's see how it works. So we begin with the same thing, AB of length 7.6 centimeter. Now we know that the ratio is 2:5. From A, draw a line AX, and from B, draw another line BY as shown in the figure. Now we know that the ratio is 2:5, so take 2 divisions on AX, that is the line below, and take 5 divisions on BY, that is B1, B2, B3, B4, B5. Now all you have to do is, the ratio is 2:5, I am repeating it again. So join A2 to B5. You can see the line A2 B5 is cutting the line AB at a point. Name it C. So again we have got a point C, that is sectioning the given line AB in the ratio 2/5. I hope you understand. Again, the steps of construction for the general method: to begin with, draw the line segment which specified in the question. So AB, that is 7.6 centimeter. Let the ratio of division be m/n, that is 2.5. Now from first point, draw another line with m divisions, that is AX with A1 and A2, 2 divisions. And from the other end, draw another line with n divisions, that is BY from B with 5 divisions, B1 to B5, 5 divisions. Now connect the mth division and nth division of both the lines to get the point of division of the line segment. So join A2 and A5 to get C. That's how it's done. Now we have to measure the values that we have got, as in AC and BC have to be measured. Now how will we know if our measurements or our construction is precise? That's why we do the verification. We know that AC by CB is equal to 2/5. We can say AC by AB, that is a whole, is 2/7, part out of the total. Similarly, CB by AB will be 5/7. Now putting the value of AB as 7.6 in both the equations, we can find the value of AC as well as CB. We will get AC as 2.2 centimeter and BC as 5.4 centimeter. So that is how the value should come. Values of AC and CB should come. Now if you measure, if you are getting 2.2, then your construction is absolutely correct. 2.2 and 5.4 has to be got. So if you have got that, your construction is perfect and you may proceed. Alright? Okay, now we move on to the next question. Draw a line segment AB of length 10 centimeter and divide it in the ratio 6:4. Measure the two parts. So in the previous question it was 2/5. Now the ratio is 6/4. It's an improper fraction. Let's see how it works. So the AB line with 10 centimeter has been constructed. Again, from A we are drawing a line AX, and now the ratio is 6:4. So the total number of parts is 6 plus 4, that is 10. So you have to make 10 divisions on this line AX. A1 to A10, 10 divisions. Now connect A10 to B with A10 as center and A10, A9 as radius. Draw an arc. Do the same procedure at the numerator of the ratio, that is 6. So do the same procedure at A6. Draw another arc with A6 as center and A5, A6 as radius. Now using the compass and the pencil, take the gap between A9 and the line A10B, the gap. Now with that gap itself and keep the compass at A5, then cut an arc. Now join A6 to the intersection of the arcs and connect it back to AB. We will get that new point as C. Now you can see that AC is bigger than BC. So as per the theorem, as per the ratio, it is 6/4. So 6 is bigger than 4. So AC is bigger than BC. We got it, right? Now again, how to verify the measurement? AC by BC is 6.6 by 4. We can write part by whole. So AC by AB will be 6 by 10. BC by AB will be 4 by 10. Now putting the values, we will get the value of AC as 6 centimeter and BC as 4 centimeter. Now after construction, when you measure, if you have got 6 and 4, bravo, good job. Your construction is well done. Alright. So now we move on to the second type of construction. Triangles similar to a given triangle as per a scaling factor. What do you mean by a scaling factor? You might have studied in the chapter triangles that when two triangles are similar, their sides are proportionate. Means that the ratios of their areas will be the same, will be a common ratio. Now that common ratio is what we call a scaling factor. So the first question, here it goes. Construct a triangle of sides 4 centimeter, 5 centimeter and 6 centimeter, and then a triangle similar to it whose sides are 2 by 3 of the corresponding sides of the first triangle. So we have to begin with a triangle measuring 4, 5 and 6 centimeter each. Let's begin. Draw BC which measures 6 centimeter. Now with B as center and 4 centimeter radius, cut an arc above BC. Now with C as center and 5 centimeter radius, cut another arc that will intersect the previously drawn arc. Now that point can be named as A. Join AB and AC, we will get the the given triangle 5, 4 and 6. That is ABC. Now we have to draw the similar triangle. Now draw a line BX from B, and again we have to make few number of divisions. Unlike division of a line segment where we used to add all the ratios, we don't have to add in this one. In this, when it comes to construction of similar triangles, the maximum value in the scaling factor can be taken as the number of divisions. As in 2 by 3, 3 is greater. So we only need to make 3 divisions. I hope my point is clear. Alright. Now again join B3. So in the line BX we have made 3 divisions, B1, B2 and B3. Now join B3 to C. With B3 as center and B3, B2 as radius, draw an arc which cut the line B3C. Now do the same procedure with B2 as center. Why? In the ratio it's 2 by 3. So we had drawn an arc at 3 as well as we have to draw a 2. So with B2 as center and B2, B1 as radius, draw another arc. Again measure the gap between B2 and the line B3C. Draw the same gap or with the same radius and keep the compass at B1 and cut an arc. Now their meeting point will be connected to B2 and extend it so that it touches BC at a new point C dash. I hope this step is clear. As you can see, we are demonstrating it while I am explaining. So we had got the new point C dash. Now we have to follow the same procedure of drawing parallel line within the triangle. So let's see, draw an arc of any radius at the point or at the vertex C of the first triangle. Now do the same step by drawing an arc at the point C dash. Now again take the gap between the side AC and side BC where the arc is touching. I repeat, take the gap between BC and AC where the arc is touching. Now with that, draw the same arc at the new arc and connect it to C dash. We will get another line parallel to AC as you can see, and name the new point as A dash. Now we had got a triangle similar to triangle ABC, and the new triangle is called A dash B C dash. So A dash B C dash is our required triangle. Now moving on to the steps of construction, we will recollect how we did construct this similar triangle. We started with the given triangle 5, 4 and 6 centimeter, or whatever is given in the question. We only used ruler and compass for construction. Then from any vertex, draw a line with maximum number of divisions depending on m by n. M by n can either be a proper fraction or an improper fraction. Whichever is the largest, take that many divisions on the new line. Now from the nth division, connect the other vertex. Then draw another line segment parallel to the first line drawn just now, and repeat the same process within the triangle. We will get the similar triangle. Let's have a look at the justification of this construction. As in, on what grounds is this construction correct? So, in triangle BB3C, you may observe the figure that has been shown in the screen right now. In the triangle BB3C, we know that B2C dash is parallel to B3C. So we can apply basic proportionality theorem or Thales theorem and write BB2 by B2B3 is equal to BC dash by C dash C, and that will be equal to 2 by 1. How do we know that? Have a look at the triangle, the side of the triangle BB3. So in BB3, there are 3 equal divisions, right? B1 is the first, B1B2 is the second, B2B3 is the third. So there are 3 divisions, and out of that, 2 are covered in BB2 and 1 is covered in B2B3. So that's how we get the ratio as 2 by 1. So the ratio BB2 by B2B3 is equal to BC dash C dash C by BPT, and that both of those are equal to 2 by 1. Or we can reciprocate that. We need the C part. So we'll write C dash C by BC is equal to 1 by 2. BC dash, is equal to 1 by 2. Now add 1 on both sides, as in C dash C by BC dash plus 1 will be equal to 1 by 2 plus 1. C dash C plus BC dash will give you the total length BC. So the equation will become BC by BC dash is equal to 1 by 2 plus 1 is 3 by 2. Or reciprocating, we can write it as BC dash by BC is equal to 2 by 3. So BC dash by BC is equal to 2 by 3. Now have a look at the triangle ABC. In triangle ABC, we had already made the construction that C dash A dash is parallel to CA. C dash A dash is parallel to CA by our construction, which means that BPT can be again applied to that triangle ABC. So we can write BC dash by C dash C is equal to BA dash by A dash A. That will be 2 by 3. So we can prove that, hence we can prove that those triangles A dash B C dash and ABC are similar. So hence proved they are similar. That's what we needed to construct, similar triangles. Moving on to the next question. Construct a triangle with sides 5 centimeter, 6 centimeter and 7 centimeter, and then another triangle whose sides are 7 by 5 of the corresponding sides of the first triangle. So again, the given triangle is of sides 5, 6, 7 centimeter respectively, and we have to draw a similar triangle 7 by 5. I might have already mentioned that the scaling factor can or cannot be a proper fraction. Like in the previous question, it was 2 by 3, a proper fraction. Now here it's 7 by 5. One thing you have to remember is that when the scaling factor is a proper fraction, the required triangle will come inside the given triangle. Like in the previous case, the new triangle was inside the triangle ABC. But when the fraction or the scaling factor is an improper fraction, like in this case, the required triangle will come outside the given triangle. Please make a note of it. So let's begin. Construct BC with length 5 cm and with C as radius and B with 6 cm as radius and B as center. Draw an arc. With 7 cm as radius and C as center, draw another arc. Mark those points as A and join B and C to A. We got our first triangle ABC. Now we have to draw the other triangle, that is 7 by 5 times the given thing. So for that we have to construct a line BX and make, so how many divisions do you think will be needed in BX? Unlike division of a line segment, we don't have to add them. All we have to take is the greater number in the fraction. So in this fraction, 7 is the greater number. So we are going to take 7 divisions in BX, namely B1, B2, B3, B4, B5, B6 and B7. Now I have already specified that the required triangle will come outside the given triangle. So what we have to connect is the ratio is 7 by 5. So 7 should stay alone, should stay free. So we have to connect B5 to C to the given point. So connect B5 to C. Now draw an arc with B5 as center and B4, B5 as radius. Draw an arc, and you might have understood that this arc drawing is for the purpose of drawing parallel lines. So draw the arc at B5 with B4, B5 as the radius. Now draw the same arc at B7 as well with B6, B7 as the radius. Now take the width of the line B5C and B4, B5, take the width. Draw an arc with B6 as center on the previously drawn arc. Then join B7 to the intersection points of the arc as you can see now. Now you got a new point along the line BC. So name it as C dash, that is one side or the one vertex of our required triangle, C dash. Now again we have to draw another line parallel to AC, where AC is the side of the given triangle. How do you draw parallel line? By cutting arcs. Do the same process again and draw C dash, a line through C dash so that line is parallel to CA. So we can name the new point where it touches the other arm as A dash. Here comes the next question. Construct a triangle ABC in which AB is equal to 4 cm, BC is 5 cm and angle B is equal to 120 degree. Construct another triangle, triangle AB dash C dash, similar to ABC such that AB dash is equal to 4 by 5 AB. So again I have given some conditions to draw our first triangle ABC. Now we are asked to construct another similar triangle such that AB dash is equal to 4 by 5 AB. AB dash is the required triangle. Now if we transpose the term AB to the other side, then it will become AB dash by AB is equal to 4 by 5, which means side of AB dash is lesser. So the required triangle will come inside the specified triangle. So let's begin. So we are starting with AB 4 centimeter and with B as center, construct 120-degree angle. You can either use a protractor or a compass method, that depends on your subject teacher as well. So I'm constructing a 120-degree angle using a protractor here. Now that will be side vertex C, which is such that BC is equal to 5 centimeter and join AC. Now draw a line AX, and here 4 by 5 is a scaling factor, so make 5 divisions A1, A2, A3, A4 and A5 along the line AX. Then connect A5 to the vertex B. From A4 draw another line parallel to A5B now and name that point B dash. So we have now got B dash. Now draw another line parallel to BC through B dash using the compass method and name the new point as C dash, and A, B dash, C dash will be our required triangle. So that is similar to the given triangle, and that is inside the given triangle as well. Next we shall move to tangents of a circle, construction of tangents to one circle. So the question, draw a circle of radius 6 centimeter. From a point 8 centimeter away from its center, construct a pair of tangents to the circle and measure their lengths. So we are asked to draw a circle of radius 6 centimeter with say center O, and from O we have to take another point which is 8 centimeter away from the center. Then draw 2 tangents to the first circle. So we shall begin with a circle with radius 6 centimeter and center O. We have to draw a line 8 centimeter OA, so that OA is equal to 8 centimeter. Now we shall draw perpendicular bisector to the line OA and name the point of bisection as B. We have drawn OA as 8 centimeter and drawn perpendicular bisector to OA, then named the point of bisection as B. Now with B as center and OB as radius, draw another circle. You may use dotted lines. Now we can see the new circle is touching our given circle at 2 points above and below OA. We can name those points M and N. M and N are the points of contact of the 2 tangents. Now we can connect AM and AN. So AM and AN are the required tangents. Simple, right? Now the steps of construction is easy. Draw circle with specified radius. Connect the center of circle to the point from which tangents are to be drawn, that is A, OA here. Construct perpendicular bisector to this line, that is draw perpendicular bisector to OA and mark the bisecting point, that is B in our case, in the previous case. With bisecting point as center, that is B as center, and its gap with center of first circle as a radius, draw a second circle. The meeting point of both the circles will be the points of contact of the tangents, that is M and N. Now join those points of contacts with the required point and we will get the required tangents. Let's move to another question. Construct a tangent to a circle of radius 4 cm from a point on the concentric circle of radius 6 cm and measure the length. So the question is saying we have to draw a tangent to a circle of radius 4 cm not from any point. We have to draw the tangent from a point on a concentric circle. So there are two circles sharing one center. So let's begin with our required circle, that of radius 4 centimeter, and we can see a concentric circle with radius 6 centimeter. Let O be their center. Now we have to pick any point P on the big circle. So I had taken P on the other side and joined OP. Alright, now we have to draw the perpendicular bisector of OP and name the bisecting point as M. Now, with M as center and OM as radius, draw a new circle. You can use dotted line again, and the point of contact of the new circle with the inner circle, we can name those points as Q and R. Now you may join PQ and PR. So PQ and PR are the required tangents. Moving on to the next. Draw a pair of tangents to a circle of radius 4.5 centimeter which are inclined to each other at an angle of 45 degree. You might want to recollect, you might have to recollect the concepts you studied in the chapter circles. In circles, when two tangents are inclined to an angle, that angle and the angle subtended by the points of contacts at the center will be supplementary. I'll repeat, if two tangents are drawn from an external point at an angle, that angle formed between the tangents and the angle subtended by the radii from the point of contact of those tangents will be supplementary, means that their sum will be 180 degree. So here the tangents are inclined to each other at 45 degree. So the angle formed at the center will be 180 degree minus 45, that is 135 degree. Now we shall begin the construction. Fix a center O and draw a circle with radius 4.5. Draw one radius OA. Now at O we shall construct 135 degree angle. So the first step is construction of 90 degree angle. So we shall begin with 90 degree, then go to 120 degree, then come back to 135 degree. So we had constructed 135 degree angle O, 135 degree, and connect angle O through the point of intersection of the arcs to the other side of the circle and name it as B. Now we can see OB and OA are the two radii to the circle. Now we know that by theorem 1 in circles, the tangent to a circle and the radius are perpendicular at the point of contact, or the angle formed between the radius of a circle and the tangent at the point of contact is 90 degree. We have to construct 90 degree on either sides of OA and OB at A and B respectively, or both. So we have to do construction of 90 degree and extend a line from A. As you can see, extended a line from A. Similarly, draw 90 degree angle and extend a line from B, and the point where they both will meet can be named as P. And the angle APB will be equal to 45 degrees. So PA and PB are the required tangents and angle P is now 45 degree. Completed. Now tangents to two circles. In the previous questions we were constructing tangents to single circle, but now we have to learn drawing tangents to two circles at once. Let's see how. We shall go to the question now. Draw a line segment AB of length 8 cm. Taking A as center, draw a circle of radius 4 cm, and taking B as center, draw another circle of radius 3 cm. Construct tangents to each circle from the center of the other circle. So there are two circles. From each circle we have to draw tangents. So there will be 4 tangents in all. Let's begin. We shall begin by drawing the line segment AB with length 8 centimeter. Now with A as center and 4 centimeter radius, we shall draw a circle here. As you can see, now with B as center and 3 centimeter radius, we have drawn another circle. We can see, now take the perpendicular bisector of AB again. So that with the point of bisection as center and the distance between the point of bisection to either A or B as the radius, draw another circle. Now you can see the third circle is touching both the circles and those will be the points of contacts. So from A, draw tangents to R and S, and from B, draw tangents to P and Q. So AR and AS are the tangents for the second circle and BP and BQ are the tangents for the first circle. Now we shall move to solving the questions. Short answer type questions carrying 2 or 3 marks. So draw a triangle ABC in which AB is equal to 5 centimeter, BC is equal to 6 centimeter and angle ABC 60 degree. Then construct a triangle whose sides are 5 by 7 times the corresponding sides of triangle ABC. So we shall begin with AB, that is 5 centimeter, and we shall construct BC 6 centimeter, and we have constructed 60 degree as you can see here, 60 degree construction. Now join AC, we got the required triangle. Now draw a line AX and make 7 divisions because scaling factor is 5 by 7. 7 is greater than 5. So make 7 divisions, join A7 to B, and from A5 draw another line parallel to A7B. Name the new point as B dash. Now from B dash join another line parallel to BC and name it as C dash. So A, B dash, C dash is the required triangle. Now here comes the next question. Construct a right triangle in which sides other than the hypotenuse are of length 6 centimeter and 8 centimeter. Then construct another triangle whose sides are 3 by 5 times the corresponding sides of the given triangle. So we are supposed to construct a right triangle with sides 8 and 6 other than hypotenuse. And we have to construct another triangle that is similar to it at a scaling factor 3 by 5. 3 by 5 means it's a proper fraction. So the required triangle will be smaller than the given triangle. So let's begin by drawing the line AB with 6 centimeter and BC as 8 centimeter. And to draw BC, we have to construct the 90 degree angle using compass. So construct BC and join AC. Now draw AX with 5 divisions because the ratio is 3 by 5. So there are A1, A2, A3, A4 and A5. Now connect A5 to B. From A3, draw another line that is parallel to A5B. So name the new point as B dash. From B dash, draw another line that is parallel to BC. So name the new point as C dash. Now we got our required triangle, the small one, named A, B dash, C dash. That is also a right triangle. Now the next question, draw 2 tangents to a circle of radius 3.5 centimeter from a point at a distance of 6.2 centimeter from the center. So let's begin with a circle with center O and radius 3.5 centimeter. Now locate a point P at a distance 6.2 centimeter from O. So OP is 6.5. Now draw or construct perpendicular bisector to PO and name the point of bisection as C. With C as center and OC as radius, construct another circle. Now the points where the two circles touch, let those points be A and B, and now you may join PA and PB. So PA and PB are the required tangents. Now the next question, draw a circle of radius 4 cm. Draw two tangents to the circle inclined at an angle of 60 degrees to each other. So it's the angle of inclination between the tangents. So again, the angle at which the tangents are inclined to each other is supplementary to the angle subtended by the radius at the center. So if the angle of inclination of the tangents is 60 degree, then the angle of inclination of the radius of the radii will be 180 minus 60, that is 120 degree. So let's construct radius OA. Then at O we may construct angle 120 degree. We should first draw 90 degree, then go to 120 degree and draw 120 degree from O and name the other radius as OB or the point as B. Now draw 90 degree angles at angle A and at point A and at point B on either sides of angle O. Now extend A as well as B and the meeting point, let it be P. So PA and PB are the required tangents and their inclination is now 60 degree. Angle in the middle is 120 degree and the inclination between the radius and the tangents will be 90 degree as per theorem 1 of circles. Now we shall move to long answer type questions carrying 4 or 5 marks. The first question, construct an isosceles triangle whose base is 6 cm and altitude is 4 cm. Then construct another triangle whose sides are 3 by 4 times the corresponding sides of the isosceles triangle. So let's begin with BC is equal to 6 cm. Now with B as center and more than half as radius, cut two arcs, and with C as center and more than half as the radius, cut another arcs. Now the meeting point of the arcs will join, or joining the meeting points, we will get the perpendicular bisector for AC. Why do we need to draw perpendicular bisector for the triangle? Because they had specified it is an isosceles triangle. In an isosceles triangle, the altitude and the median are the same. That means the altitude, that is 4 cm in this case, will divide the base, that is BC, into 2 equal parts. So now along the perpendicular bisector, mark 4 cm, name it as A. Now you may join AB and AC. So we have obtained the given triangle ABC. Now we may draw another line BX and make 4 divisions, B1, B2, B3 and B4, because in the ratio 3 by 4, 4 is the largest number. So B4. Now from B4 we shall draw a line to C, then from B3. Why? Because it's 3 by 4 is the scaling factor. So from B3 draw a line parallel to B4C. Now let the new point be named C dash. Now from C dash draw another line towards the BA side so that that line is parallel to CA. You know how to construct parallel lines and name the new point as A dash. So A dash, B, C dash will be the required similar triangle. Now we shall move on to the next question. Draw a line segment AB of length 7 cm. Taking A as center, draw a circle of radius 3 cm and taking B as center, draw another circle of radius 2 cm. Construct tangents to each circle from the center of the other circle. This is the same concept, tangents to 2 circles from each other. So we shall begin with AB, that is 7 centimeter. It's given. Now with A as center, let's draw a circle of radius 3 centimeter. And with B as center, let's draw another circle with radius 2 centimeter. Those will be on either ends of AB. Now we shall draw the perpendicular bisector for AB. Now with the point of bisection as center and the gap between point of bisection and A or either B as the radius, draw a new circle, as you can see, the middle one, and the points were the middle circle touches both these other circles, be P, Q and RS. Join AP, AR and AS. Similarly, join BP and BQ. So BP and BQ are one pair of tangents and AR and AS is the other pair. So we got two pairs of tangents or 4 tangents in total. Next question, draw a circle of diameter 7 centimeter. Mark a point M at a distance of 9 centimeter away from its center. Construct a pair of tangents to the circle through M and measure their lengths. Easy, right? So we shall draw a circle of diameter 7 centimeter or radius 3.5 centimeter. Let the center be O. From O, we are marking a point M at a distance 9 centimeter. So that OM is 9 centimeter. Now we shall draw the perpendicular bisector to OM. Now we shall draw the circle with point of bisection as center and O and point of bisection as radius. We drew another circle, the dotted circle. Now the point of contact are the points where the new circle touches the first circle. So we can name those A and B. Now we shall join MA and MB. MA and MB are the required tangents. Now we shall move on to the next question. Draw 2 concentric circles of radii 3 centimeter and 5 centimeter. Construct a tangent to smaller circle from a point on the larger circle. So we shall begin with O. A center O has to be fixed because we have to construct concentric circle. So with O as center and 3 centimeter radius, we shall draw the smaller circle, and with same O as center and 5 centimeter radius, we shall draw the next circle. So we got the set of concentric circles. Now connect O to any point on the bigger circle and name it as P. So OP will be a line. Now construct a perpendicular bisector to OP, and from the point of contact or from the point of bisection with that as center, draw a circle, a new circle. Now the circle, the point where the new circle will touch the small circle will give you the points of contact. We can name them A and B. Join PA and PB and we will get the tangents. And on measuring, we got that PA and PB both measure 4 centimeter. You shall try it. Now moving on, draw a triangle ABC with BC 7 centimeter, angle B 45 degree and angle A 105 degree. Then construct triangle whose sides are 4 by 5 times the corresponding sides of triangle ABC. So we shall construct a triangle ABC with 45 degree and 30 degree because we don't know the construction of 105 degree. So we shall draw angle BC 7 centimeter, and from B we shall construct 45 degree, extend it, and from C we shall draw 30 degree and extend it. How did we get 30 degree? Upon applying angle sum property. 45 plus 105 is 150. 180 degree minus 150 degree will give us 30 degree. So angle C measures 30 degree. So draw these two lines and the point where the two lines intersect, name it as A. So ABC is the required triangle. Now from B, draw a line BX, give 5 divisions because the scaling factor is 4 by 5. So B1, B2, B3, B4 and B5. From B5, connect B5 to C. Draw another line from B4 which is parallel to B5C and name the new line as B4C dash. From C dash, draw another line that is parallel to CA using the compass method. So we can construct C dash A dash parallel to CA. Now we got A dash B C dash, which is the required triangle. Thank you.